welcome back. This is Chem 1804. I'm Dr. Hathcock, and I'm here with Dr. Alaban, and we are going to do a qualitative synthesis of aspirin. So we are going to look at the medicinal side of chemistry today and test a couple of different aspects here. And I'm quickly going to run through your components of this lab. So you'll have your disposable pipettes, your pH paper, of course. You'll need, no scale today. You will have willow bark. Now willow bark is the natural form of aspirin. It is still used by many who prefer homeopathic forms of aspirin, which we use today to reduce pain, reduce inflammation. And one of the things that the pharmaceutical industry is using aspirin for is to check on complications in pregnancy, diabetes, colon, etc. Well, willow bark, because it is homeopathic, one of the ways that patients who choose to go the natural way get the aspirin out of it is they will make a tea out of it. Another option is you can chew on willow bark if you can actually get bark in its natural form. It's not the most pleasant tasting items, okay? And if you've ever had actual aspirin, you know it has an actual bitter taste. One of the items that you will need to provide for your lab that is not provided in the kit is actual uncoated aspirin. You need to get the non-coated. Now, if you want to add a little bit of fun to this actual lab, you can actually get coated and coated. So an uncoated tablet of aspirin and a coated version of aspirin. So you need one of each.
But you must have the uncoated.
Okay, so Dr. Alaban's in the back. She's actually directing today's video. And then you will be getting in the packet the salicylic acid, which is the main component of your willow bark and our pharmaceutical grade aspirin. And then the I always screw up this particular long chemical word. It's the acetylsalicylic acid.
Acetylsalicylic acid. That's the organic portion of the name.
Okay, so today you are going to be looking at, again, like I said, the pharmaceutical side, but we're going to be doing an organic chemistry experiment basically, and you're going to be testing, of course, pH, and you're actually going to synthesize, meaning you're going to pull out the salicylic acid from willow bark. You're also going to be pulling out or looking for a phenyl group, which is often your R found on your chemical analysis. And then we're going to compare some properties of your salicylic acid and your acetylsalicylic acid.
Acetylsalicylic acid is also commonly referred to as aspirin.
Okay, so those are the background and your components. Oops, forgot the actual chemicals, sorry. Then you'll have acetic acid here and your ferric 3 chloride or iron 3 chloride and your ethanol. Okay. In addition to that, here is the chart where you will be notating color changes and your pH values and pretty much your physical and chemical changes. So that foundation that you learned back in 1802 is going to come back again here, because this is where we determine if we have just a physical or a chemical change in our experiment. Now I want to remind you, CC means clear and colorless. I also want to remind you that you never write no reaction. There's always something going on between two compounds. Okay. All right, so the first thing is we have the well plate. Now the well plate came with the kit as well. And on the well plate, not that you can see it quite yet, but your well plate is numbered from left to right when you look at it, or in this case, your guys, when you're looking down, or from my side, it's right to left. And you are given the chart, and you couldn't see it on the well plate, but you will see A1, A2, etc., B1, C1 for each row and column. A being your rows, 1 being your columns. And these are on your well plates, and they'll help you keep track of what you're working on. You'll need a white sheet of paper to help you with the background to look for colors. So what I'm going to do is I'm actually going to put a small amount of willow bark in A6. Now it says a small scoop, not very much. And the reason I'm doing that one first is because that one has to actually sit for 30 minutes. And the longer it sits, the more you will actually pull out. Now I'm going to add to my willow bark, I believe it is, let me double check here.
Ethanol, I think.
Yeah. Yep, ethanol. Okay. All right, now you're going to add just enough ethanol to the willow bark so that it's completely covered. Okay. And Dr. Alaban, you can see that I've completely covered it. Because remember, we're doing an extract here, which means we need to pull our aspirin out of the willow bark. Okay? So that's why I did that one first. The longer it sits, the more we're going to pull out. All right, so now I'm going to put in A1 my salicylic acid. And apparently I did not cut. Oh, yes, I did. Okay. So I'm going to put a little bit in my A1. And they send you plenty of chemicals for you to repeat the process if we have any mistakes.
Yeah, and if I have any questions about your results, you could quickly just do a quick retest.
Now I want to remind you that you are going to be taking pictures of your results, and since this is the millennial generation, I don't need to remind you of what a selfie is, but I will just so that there are no misunderstandings. A selfie is a picture that includes you and your item. So,
and note what Dr. Hathcock is wearing, because I will, this is your warning, be specifically looking for these items if you want extra credit on this.
My glasses.
And even all points on future selfies.
My gloves. And my apron that came with my kit. Okay, so I've now put in my salicylic acid, my acetylsalicylic acid, see, the faster you say it, the easier it is, and my willow bark. So this is A1, A2, and A6. It's upside down for you because I'm looking at it. All right, so now, after that, I'm going to add my liquid reagents. So I'm going to add 15 drops of ethanol to B1. So 1, 2, 3, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. And let's see. I have that there. And then to B3, I'm going to add my iron chloride.
This stuff is brown, so make sure you wear gloves for sure.
Oh yes, iron stains. Okay, so B3, we have 1, 2, 3, 4, 5, 6, 8, 9, 10. One too many. We're okay though. All right. Okay. All right, so that should basically cover my main steps here. 1, 2, willow bark, added, ethanol, solid materials, okay. All right, and then in 10 drops, 3 to B4. That was the last one, acetic acid. Okay, so now I basically have all of my reagents set up, okay? Now, I've added ethanol to my A6 and I'm allowing it to sit for 30 minutes. Now, we're waiting for all this to process. I'm going to move on to the pH determination of the other items that I can work on while I am processing my willow bark. Okay. So ahead of time, I went ahead and I labeled my disposable pipettes with ETOH for ethanol. That's a shortcut that's used in chemistry. The FeCl3 for my ferric chloride or iron 3 chloride, and then my AA for my acetic acid. Now I'm going to use the ETOH pipette and I'm going to transfer 10 drops of my ethanol from B1 and I'm going to transfer it to A1, which has my salicylic acid. Okay. All right, and then I'm going to use my stir rod. Now remember, your stir rods came with your equipment, and I have a wash bath here because, again, we know we can't transfer between different items. I'm going to stir, and then I'm just going to take a piece of my pH paper, and I'm going to use the tip of my stir rod and touch. I can leave this on my white paper and I will note my results here. Now I don't want to give this away, so I'll let you guys decide what you find out. And I'll put my stir rod in my wash and I'll repeat the process here again. I'm going to use my ETOH from B2 and I'm going to transfer that to A2. Okay, and I'm going to stir. I'll use a fresh piece of pH paper, and I will note the results. Put my stir rod back in my wash for later use. Record my observations here. Okay. All right, now we're going to move along and we're going to do the iron chloride test. So I'm going to use the pipette that I have labeled with iron chloride here, and I'm going to transfer from B3 into A1, which is my salicylic acid. Yes, I know I've already transferred ethanol into A1, but we are now going to transfer the ferric chloride. So B3 into A1. Now I'm only going to put in 1 drop. Take your stir rod. Notice here, we started out with a white powder. I added ethanol. You wrote your descriptions down. Notice here in A2, which also has ethanol, it was a white powder. So with the salicylic acid, I've had a color change. Okay, So now I'm going to take and transfer 1 drop of my iron to my from B3 to my A2. I will use my stir rod. And you will write down your results on your activity sheet. Make sure you're using descriptive words. This is a qualitative, not a quantitative. So make sure you're using words to describe. Is it clear? Is it colorless? Is it dissolving? Yes or no? Okay. All right, so now let's determine some salicylic acid. Our willow bark over here has been soaking for 30 minutes. Okay, so we're going to take, and I'm going to use my stir rod, and I'm going to really see about making sure it's evenly distributed in that ethanol. Okay, so I'm going to use my ethanol pipette here. And I'm going to transfer 10 drops of the willow bark extract from my A6 to my A3. Okay, so make sure you don't confuse which well you're working with. Oops, grabbed the wrong pipette. Let's try that again. Okay, so we're going to take, and notice here, if you have a good extract, you will often go from a clear and colorless to a change in color. Willow bark, because it's a bark and brown, will often extract a color. So I'm going to put 10 drops in A3. Okay. All right, and I'll stir again. All right, I want to test the pH, so I'll do the same thing here. Use what's on my stir rod. It only takes a little. You can see a change. If you don't see enough on there, feel free to add a little bit more. Okay, and it may or may not be easy to tell if you have a color change or not, so use your white paper and write down your descriptions here, again, from well 1, 2, 3, so we're in well 3 here. And note your pH change. Again, I'll leave those descriptions up to you. Finally, we're going to take and we're going to transfer some of the acetic acid. And we're going to transfer, I want to make sure I'm on the right step here.
I think you have to put willow bark in A4 as well.
Okay, so.
Because what you're going to do is now look at the change in willow bark when you add in the acid. So A1 through A3 are your controls. A4 is where you're going to add willow bark.
Today, yeah, see, I didn't want to get lost here. Okay, so A6 to A, oh, now I need to do A6 to A4.
So you need to put willow bark in A4.
Yeah, that's what I need.
And then you're going to add acetic acid to that.
Okay. So now we got this last one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now I have willow bark in A4. Now I'm going to use the ferric chloride here from B3 to A4. So 1, 2, 3, 4. Whoops, only need 1. Oops. We got a little bit there, too much. We're going to stir. Okay. Note we have a color change. Okay. And then finally is the last one. We're going to pull our last pipette. And here we're going to pull from A4, and A4 is your acetic acid. And we're going to put this in B4. Okay, so we're going to transfer to see whether or not we pulled any Okay, so we have acetic acid added. Okay, let's make sure our stir rod is clean. Okay, and our last pH paper. And record your results. Thank you, and we'll see you next time.